Okay, so this is page 2 of binomial expansion. Let's just take a look at what page 2 looks like. Now we're going to do to the 5th power, we're going to do to the 6th power, and then we're going to do a special problem here. Okay, so let's get on with it. I'm going to use the templates again. Of course, after you do a few problems, maybe you find you don't need the template anymore. You're not going to have the template on the exam, but once you get used to using the template, I think it'll get you in the habit of doing things the right way. Okay, so the 5th. So it turns out that the Pascal's triangle coefficients for row 5 is 1, 5, 10, 10, 5, 1. We can kind of remember that because we know the previous row, we know 1, 4, 6, 4, 1, right? And we could just add the two, neighboring coefficients, and then we get the 5 row. By the way, we could get the 6 row similarly by adding up all the neighboring numbers. Okay, so you don't really have to memorize the whole thing, but if you have up to 1, 4, 6, 4, 1, you can easily get to 6, right? And for the binomial expansion exam, you're going to have to generate that with Pascal's triangle, and Pascal's triangle is not on the formula booklet, unfortunately. Okay, so since the next problem is x plus 2 in the binomial to the 5th power, we know that the Pascal's triangle coefficients are, oops, I'm writing them in the wrong place. Don't do what I do. So the triangles are where we're supposed to put Pascal's triangle coefficients. Okay, and that'll start us in the right spot. The circles will, oops, the circles are x's. Okay, and then the 2's are in the squares. Okay, and then I'm going to put to the 5th power, to the 4th power, to the 3rd, to the 2nd, to the 1st, to the 0. And then I'm going to start counting up from 0. One thing you might notice is like all of these exponent pairs, if you add them together, you're going to get 5. Pretty good way of checking if you wrote them correctly. Now I'm going to cross out things that are equal to 1. Okay, I think that's it. All right, so I'm going to put x to the 5th plus 5 times 2, which is 10, x to the 4th. Let's see, that's a 10, by the way. 10 times 2 squared is 40. And x cubed. And then 10 times 2 cubed, by the way, is 8. So that would be 80. X squared. 5 times 2 to the 4th. 2 to the 4th is 16. 5 times 16 is 80, I think. Yeah. $80x. And the next one is 2 to the 5th. 2 to the 5th is 32 because 2 to the 4th is 16. Okay, so there's my answer for the 3A. 3D is this one here. So Pascal's triangle coefficient, those are pretty easy. We just did that. 1, 5, 10, 10, 5, 1. Oh, by the way, I didn't put the plus signs here, but that didn't bother you, right? Okay. As we go along, we don't need to use, this so religiously. Now, when you do the exam, you're going to put parentheses instead of these shapes, and you are going to put the plus signs in religiously, because if you mess up at the end, you'll get partial credit for putting the plus signs. So the circles are all x's. The squares are negative 1 over x. And then I put the exponents starting from 5, counting down. Oops. and then starting from 0 and counting up with the squares. Okay, and I'll put the plus signs in. And then I can cross out the things that are equal to 1. Anything to the 0, remember, is 1. And then I can start writing out. So there's a negative here, and it's to the first. So that negative is going to come out front. And then the 5 doesn't get multiplied times any numbers because the negative 1 to the first is just negative 1. So x to the 4th divided by x is x cubed, right? X to the 4th divided by x. The next one is going to be plus 10. And the negative here is going to square, so that disappears. So it's going to be 10 times x cubed times 1 over x squared, right? And the negative disappears. The next one is going to be, the negative sign is going to cube, so it's still going to be there. So it's going to be negative 10, and then x squared, and then that will be multiplied times 1 over x cubed. I already put the negative out front. The next one is going to be, let's see, negative 1 to the 4th is positive 1 because it's an even power divided by x to the 4th. So that would be 5x over x to the 4th. And the last one would be negative 1 to the 5th, so that would be negative 1. And the bottom would be to the 5th, so that would be x to the 5th in the bottom. Okay. Now I just need to write it down one more time with the simplifications. X cubed divided by x squared is just x to the 1st, or just x, right? And the next one is negative 10, and then x squared divided by x cubed is 1 over x. And the next one is 5 times x divided by x to the 4th, so that would be 5 divided by x cubed. And then the last one is minus 1 over x to the 5th. If you want to check things, look, there's an alternating pattern of positive, negative. So positive, negative, positive, negative, positive, negative. That's a good sign. Look at the powers. The powers create a pattern too. 5, 3, 1, negative 1, negative 3, negative 5. Do you see how it's descending by 2s? That looks like a good sign too. Okay, so there's ways you can check it without actually going through all the trouble of redoing the calculation. And if you do redo the calculation, chances are you're going to make the same mistake again, right? Okay. Now in 4a, the first thing it asks is, what is the 6th row of Pascal's triangle? Okay, 4a, write down the 6th row of Pascal's triangle. We already wrote that down, right? It's 1, 1, 6, 15, 20, 15, 6, 1. And then we're going to do these two binomial expansions. We're going to do 2x minus 1 as a binomial and x plus 1 over x as a binomial. And we'll use the template for that. Okay, so first we put in our coefficients, 1, 6, 15, 20, 15, 6, 1. And then our binomial is 2x in the circle and negative 1 in the square. So put it in the wrong place. 2x, 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 and 2x, and negative 1 in the square. And then I put the powers. So remember, I start with the 6 this time and work my way down to 0. And then I start from 0 and work my way up. And then I cross out things that are 1. 1, that's a 1. Negative 1 to the 6th power, that's a 1 too, right? All these negative 1s to an even power are going to be 1 also. Okay, now let's see. This would be 2 to the 6, x to the 6. And 2 to the 6, if you put that in the calculator or multiply it out, is 64. 64x to the 6th. The next one is 2 to the 5th, x to the 5th. So that would be 2 to the 5th is 32. And then it's times negative 1 to the first, so that would be a negative. The next one is, the next one is 15 times 2 to the fourth, x to the fourth, right? So 2 to the fourth, x to the fourth, that would be 16x to the fourth. And then the next one would be 20 times 2 cubed x cubed, so that would be 8x cubed. And then negative 1 cubed would be a negative sign. And the next one would be 15 times 2 squared x squared, which would be 4x squared. And the next one, the negative 1 to the fifth, would just be a negative sign, right? And then 6 times 2 would be 12x. And the last one, everything's 1, so it would just be plus 1. Sorry, I didn't put the plus signs again, didn't I? 6, now I'm going to rewrite and simplify for the last time. 6 times 32, that would be 180 plus 12, 192x to the fifth. 15 times 16, wow, that's a hard one. So that would be 225 plus 15, that would be 240. Can verify that with the calculator. The next one would be negative 160, because 20 times 8 is 160. 15 times 4 is 60. Minus 12x plus 1. Let's make sure that the negatives alternate. Plus, minus, plus, minus, plus, minus, plus. Good, they alternate. And my x's also follow a pattern, 6, 5, 4, 3, 2, 1, 0. You're not going to really find a pattern with the coefficients. Those are harder to verify. Okay, so that was the first x to the sixth one we did. Now let's do this one here, which is a little more complicated. First step, though, is, you know, not too bad. It's familiar. And then we're going to put the circle. There's just going to be x in each circle. And then 1 over x is in each square. And then I put the exponents. So 6, starting with 6 and working my way down to 0. And then starting with 0 and working my way up. And then put plus signs in between. I always forget to do that. Okay, and then I start crossing out things that are just 1. Okay, and now I think I'm ready to start simplifying. So the first term is just x to the 6th. Second term is 6x to the 5th over x. Next term is 15x to the 4th divided by x squared. Next one is 20x cubed divided by x. And the next one is 15x squared over x to the 4th. Next one is 6x over x to the 5th. And the last one is 1 over x to the 6th, so it'll be 1 over x to the 6th. The 1 to the 6th is just 1. Almost done. So I'm going to simplify one last time. So like x to the 6th plus, and then this x to the 5th divided by x would just be 6x to the 4th, right? X to the 4th divided by x squared is x squared, so it'd be 15x squared. X cubed over x is x squared, so that would be 20x squared. Something's wrong. I didn't put the 3 here. I noticed there was a problem in the pattern. X cubed divided by x cubed is just 20. Isn't that weird? So like right in the middle of the pattern, there's a coefficient with no x term. And we're going to see that a lot in the future. X squared divided by x to the 4th is x squared in the denominator. X divided by x to the 5th is x to the 4th in the denominator. and then 1 over x to the 6. And now I think we're done. And if you check the pattern of the x's, you will see that they kind of follow like a descending pattern, counting by 2. So 6, 4, 2, x to the 0 is 1. X squared in the denominator, x to the 4th in the denominator, x to the 6th in the denominator. Isn't that cool? Okay. The next one is an interesting problem. The next one says, for this one, it gives us like an algebraic equation. So it says, okay, you have an unknown first term and an unknown second term. Let's just call them A and B. If you cube this, you get this polynomial, this cubic. And the first two terms are 8 and 12 e to the x, but we're not telling you the rest of the terms. Find what A and B are equal to. Now, don't let this bother you. The left side looks very familiar, so why don't we just expand that, and then afterwards we'll set it equal to the first two terms and see what we get, okay? So, a plus b cubed, we don't even need to use the template for that. We already know what that looks like, right? But we'll use the template just in case you forgot. So, it's cubed, so we're going to put 1, 3, 3, 1, right? And then, we don't need the rest of this. And then we're going to put in the a and the b values, but the a and the b values are just a and b. So that was easy. Then I put in the exponents, 3's counting down and then 0 counting up. So what do you know? I get the original pattern that we showed on page 1, right? And if I set this original pattern equal to the pattern they gave me, it'll give me the following. So a cubed plus 3a squared b plus 3ab squared plus b cubed. That look familiar from page 1? Now I'm going to put what they gave me underneath. So this is 8, and this is 12e to the x, they say. Okay, so the first term, they say, is 8, and the second term is 12e to the x, and we don't know what the next two are. But since we know that a cubed is 8, we can set them equal to each other and solve, and we know that a has to be 2 because the cube root of 8 is 2. If we know that a is 2, that means that we can figure out what b is too, because we know that 3a squared b is 12e to the x. And if a is 2, then that means 3 times 2 squared b is equal to 12e to the x, which means that 3 times 4, which is 12b, equals 12e to the x, which means that b is equal to e to the x. Okay, so now what they want to ask us is, okay, now that you know that the binomial is 2 plus e to the x to the third, find all the terms. Find the last two terms, because we know the first two terms are 8 and 12e to the x. What are the third and the fourth term? Well, that's easy. All we need to do, now that we know both a and b, is to expand it out, right? So the first term is 2, and the last term is e to the x. Now this is a weird b term, right? But you know, you could just put whatever you want to in there. Still follows all the rules. Starts with the 3 as the exponent, and then counts down from there. And then we start with 0 and we count up. There's a slight delay on the computer right now. And then I put plus signs in between, and then I cross out things that are 1. Anything to the 0 power is 1. And then I'm going to expand. So 2 cubed is 8. Oh, we knew that. 3 times 2 squared is 12e to the x. We knew that. Next one is, I wrote it 2 twice because the computer was weird. 3 times 2 is 6. E to the x squared is e to the 2x, right? E to the x cubed is e to the 3x, right? Okay, we're done. So the last two terms that we didn't know were 6e to the 2x and e to the 3x added together. And now I think we're done with page 2. Yep, we are.